Okay, this video is going to be about how to find limits numerically from chapter 1.2. Okay, so our first example, we are asked to find the limit as x approaches 2 of x cubed minus 8 over x minus 2. So the first thing we always want to do when asked to find the limit of a function is to try to use direct substitution. So plugging in whatever this number is, in this case 2, so plugging in 2 for every value of x. But in this case, when we plug in 2 for x, we get 0 over 0, which we can't have. So the better way to solve this limit is to come up with a table of values with a row of x values and a row of y values. So we want our x values to approach whatever this number is. So in this case it's 2. So we want our x values to approach 2 from the left and also approach 2 from the right. So in this case we have these x values in this table that approach 2 from the left and from the right. So now what we're going to do is substitute each of these x values into this function. So we'll end up doing something like this: 1.9 cubed minus 8 over over 1.9 minus 2. And with this, we get, just plugging it into the calculator, because it's unlikely that you'd be able to do this in your head. Plugging into the calculator, it's 11.41. So 11.41 goes here, and then you just keep plugging in each of these x values into this function right here. So plugging in 1.99 into this function will give us 11.94, and this one will be 11.99. So this is all approaching 2 from the left. As we approach 2 from the right, we get 12.01, 12.06, and 12.6. So as we can see from our table here, as x approaches 2 from the left, we see that f of x is approaching 12 from the left, and also it approaches 12 from the right. So it approaches 12 from both the left and right, so we can say the limit as x approaches 2 of x cubed minus 8 over x minus 2 is 12. For our next example, we can also try to use direct substitution, but again, plugging in 2 for x will just give us 0 over 0, so we need to make another table. So we continue to find x values that approach 2 from the left and from the right, and we can plug each of these x values into this function, so we will get 2 times 1.9 minus 4 over 1.9 squared minus 4. Plugging this into the calculator, you should get 0.5128. Okay. So again, just like the last example, you need to plug in each of these x values into this function. So plugging in 1.99 to this function will give you 0.5012. Plugging in 1.999 gives you 0.5001. So that's as x approaches 2 from the left. As x approaches 2 from the right, we get, plugging in 2.001 gives us 0.4998. Plugging in 2.01 gives us 0.4987. And plugging in 2.1 gives us 0.4878. So, based on this table, we can see that as x approaches 2, f of x is approaching 0.5, or 1/2. So the limit as x approaches 2 of 2x minus 4 over x squared minus 4 is 1/2. Okay, this will be our last example. So we always try to use direct substitution. In this case, again, plugging in, if we plug in -1 for each x value, we'll get -1 cubed plus 1, which is 0. -1 plus 1, which is also 0. 0 over 0 doesn't work. So again, we have to find a table of x values that approach -1 from the left and approach -1 from the right. And it's very important to make sure that you have the right sequence of x values, because if, for example, like if these three were switched up, then you'd have a problem in determining the f of x values. So it's very important to pick the correct x values here. So as we plug in the first number into this function, we get -1.1 cubed plus 1 over -1.1 plus 1. And that is equal to 3.31. So plugging in -1.01 to this function gives us 3.03. Plugging in -1.001 gives us 3.003. And then coming from the right, we have, as if we plug in -0.999, we get 2.997. As we plug in -0.99, we get 2.97. And plugging in -0.9 gives us 2.71. So again, looking at this table of values that we've made, we can see that as x approaches -1, f of x approaches 3. So we can say that the limit as x approaches -1 of x cubed plus 1 over x plus 1 is 3. And that is the end of this video. Thanks for watching.